This is a repeat of the lecture we had in class today, in case you were confused or you were absent. We are talking about the sine rule and the cosine rule. Both of these rules are used for non-right triangles. We use these rules when we do not have a right angle to use regular trig with. So SOHCAHTOA won't work for these triangles. In order to be successful with the sine rule and the cosine rule, you will have to be able to pick which rule to use, and you will also need to know how we label triangles. Now you can see that according to our rule, we have triangle ABC. A, B, and C represent the three angles of the triangle, and the sides are going to be labeled with the lowercase letters A, B, and C, with each side being across from the angle with the same letter. So for example, in triangle that I have drawn here, if I have angle A, then across from that angle A would be little a. But we don't have to stick with A, B, and C. Those were just the letters that the person who wrote the rule chose to use. We might have angle D, in which case we would describe the side across from it with a lowercase letter, little d. And another one might be angle R, in which case across from that angle would be little r. Now according to the rule, we set up a set of ratios. The ratio of the sine of the angle divided by its opposite side. So again, the letters are not so important. They just chose to use A, B, and C. When we're going to solve these proportions that we're setting up, we're actually only going to use two at a time. It will depend on the information that we're given in the triangle as to which two we use. So for example, in the triangle that I've drawn for you, we might be using the angle D and the angle R, in which case we'd set up our ratio as the sine of angle D divided by the opposite side, which is D, and that should be equal to the sine of angle R divided by its opposite side, R. One other thing to note about the sine rule is that sometimes we may want to flip our ratios over and have the side divided by the sine of the angle. We choose to do this when mathematically it works out better for cross multiplication purposes, because basically if we have two fractions and we're trying to find one of these four pieces of information, we're going to be cross multiplying. And so sometimes it works better or easier with the cross multiplication if we have our fractions flipped over. So the sine rule is used to solve problems that have two angles and one side given, or two sides and a non-included angle given, and we'll see examples of this in the next slide. So here we have case 1. In this example, we know two sides, so we have a side measure here and a side measure here, and an angle opposite one of those sides, and what we are trying to do is find an angle measure. So we're trying to find x up here. The first thing I always do is I identify my opposite pairs. Notice we haven't given anything a label at this point, but we might have been told that angle A was 115, and that makes little a 49. They are opposite pairs, an angle and a side opposite. And then I'm looking for angle x, and its opposite side is 16. So suppose we had labeled that b, then 16 is little b. So now we get our sine rule, and we put together the ratios according to the rule, matching opposite partners. So I've gone ahead and I've written the sine of x over 16 is equal to the sine of 115 over 49. All I've done is I've matched up the opposite partners. And now this is just a math problem that we need to solve. My variable that I need to know is there. There's my variable. So 16 is in the way. How would I get rid of it? Well, I can multiply both sides by 16. If I multiply this side by 16, that 16 and that 16 will cancel. So 16 will not be a part of that side. And then I'm going to multiply this side by 16. So basically what I have now is the sine of x is equal to 16 times the sine of 115 divided by 49. This entire thing is just a number. So I'm going to get my calculator out, type 16 sine 115 in. I'm going to hit enter. Then I'm going to divide by 49 and hit enter. And at this point, we will have the sine of x is equal to 0.2959. That's as much as we need to write out. Now what's important to remember here from the last or the first part of this unit is that I'm trying to find x, and x is clearly an angle measure. So now in my calculator I need to convert this to inverse sine. Inverse sine of what? 0.2959 is equal to my angle. When I type all that into my calculator, I find that x is equal to 17.2 degrees. Here we have case 2 for using the law of sines. In case 2, it says that if we have two angles and one side, and we're trying to find the other missing sides, then we can use the law of sines. Now, I don't try to memorize the different cases. I know, in general, that the law of sines is easiest to use. Because it's easiest to use, I always check to see if I can use it first. And the way I check is by looking for those opposite pairs. In this triangle, I see that angle that measures 22 degrees is across from the side that is 15 in length. So I know that if I want to, I have the sine of 22 divided by 15. The problem in this example is that the side that's labeled x is not across from anything. Look at this. Side x that I want to know is across from a great big missing hole. But that's not a problem. I know that the angles of a triangle add up to 180 degrees. So if I know that I have a 48 degree and a 22 degree, I can find out what the missing angle is. So once I have taken 180 and subtracted 22 and 48, I know that the missing angle is 110 degrees. So 110 is the angle across from x. Now this is one of those cases where I am finding that x is on the bottom. So notice what happens if I simply flip everything over. If I have 15 over the sine of 22, and that's equal to x over sine of 110, then all I really have to do is multiply both sides by sine 110. Remember, this is just a number. Sine of 110 is a number. It's not two separate things. So if I multiply this by this number, I have to multiply the other side by the sine of 110. So x is equal to sine of 110 times 15 divided by the sine of 22. I'm going to carefully put this into the calculator. I'm going to type sine 110 times 15, then I'm going to hit enter, then I'm going to hit divide by sine of 22, and when I do that, x turns out to equal 37.6. Now, this is a side. Notice we solved for x, not the sine of x. So we do not need to be worrying about finding a missing angle because that's not what we're finding. We're finding a side. So we are done at this point. X is simply 37.6. So now we're going to look at the cosine rule. On first inspection, the cosine rule looks like it's much more complicated than the sine rule, but it really isn't. It does require careful mathematics, and so writing neatly step by step will be very important. It also requires that you remember what we learned with the sine rule about labeling the triangle. Partners are always across from each other. Angle A should always be across from side A. The cosine rule is best used when we have two sides in an included angle or three sides. Primarily, you will attempt to do the sine rule, usually first of all, and you'll see that if I try to do the sine rule, I could write sine of x over 8 is equal to the sine of, whoops, I don't have another angle. Nor do I have two of the angles to find the missing angle. I'm just stuck. So I can't use the sine rule. We will have to use the cosine rule. Now let's look closely at the law of sines when we are given all three sides of a triangle. First thing I always do is I circle my opposite partnership. I find wherever the variable is and I look for the side or the angle across from that variable. And I circle them. That is an important pair to keep track of. Next, I write down my formula, and if you'll look carefully with me, these should represent these. So my opposite partners are fitting in to those places. Those are the ones that we are replacing. So 8 is my side. That means 8 is going to be first. 8 squared is equal to. Now B and C can be the other two sides, and it doesn't matter which one is which. So I'm going to just do 7 squared plus 12 squared minus 2 times, again, B and C, that's just my 7 and my 12, and then cosine of the angle I'm trying to find. Now, some careful math. And of course we have our calculators if we need it, but this early part we can do in our head. 64 equals 49 plus 144 minus, and then I type 2 times 7 times 12, that's 168, cosine of x. Now let's pause right here and look at this pair. 168 is being multiplied times the cosine of x. This pair is being held together by multiplication. That means in a minute when we want to take them apart, we're going to have to take them apart by division. So now we're going to look at what we can do to simplify this part right here. We simply add. So we have 64 is equal to, and then I would type 49 and 144 into my calculator. 49 and 144 would be 193. And then we subtract our 168 cosine of x. Now again, these units are held together, so notice I did not take 193 minus 168. We're not allowed to do that. Next step is to move the 193 over by subtraction. So I take 64 minus 193 in my calculator, and I get negative 129 is equal to negative 168 cosine of x. Now I can divide. These two are being multiplied together, so now I can take them apart. I'm dividing both sides by negative 168. So negative 129 divided by 168 comes out to be a positive 0.7679. That's all I'm going to write down, even though there are more digits, equals cosine of x. We're trying to find an angle, so I'm going to have to rewrite this as the inverse cosine of 0.7679 is equal to x, just like we did with SOHCAHTOA. And then in my calculator, do inverse cosine, and it's going to turn out that x is 39.8 degrees. Let's look at another example of the cosine rule. This is case 4. We recognize this is a cosine rule because we have two sides and the included or enclosed angle. That's another way to think about it, but we've been calling it the included angle. And we're hoping to find an opposite side. So once again, I'm going to circle my opposite pair. This is the partnership that's on either end of my cosine rule. So I practiced writing my cosine rule several times until I know it. I've got to know this for my next test. And here's the partnership that I've circled. Cosine of 87, that's going to go there. And x is going to go here because x is the side and 87 is the angle. So let's rewrite this. We have x squared is equal to b and c, they're just the other two sides. Doesn't matter what order. 13 squared plus 24 squared minus 2 times 13 times 24, and then cosine of the angle, and in this case we know the angle, so we write cosine 87. This is easier than the last one we did because we aren't dealing with a variable over there. We can simply start putting this into our calculator. So we have 13 squared, which is our 169, plus 24 squared, which is 576, minus 2 times 13 times 24 is 624 cosine 87. So I'm just trying to show you where the numbers are coming from. You could type this entire thing into your calculator in one step. And that's what I'm going to do now with this step. I'm just going to type that in my calculator exactly like I have it written. 169 plus 156 minus 624 times cosine 87 is going to give us 712.3. Now that's huge. I cannot possibly have a triangle that has a side of 13 and a side of 24 and a side of 712.3. The other two sides would never meet up and make a triangle. And that's because this is x squared that we're finding. So I'm not done yet. And if I don't remember this last step, I'm going to miss the problem. So when I'm down to x squared equals 712.3, I need to take the square root of both sides. So x is going to equal, the square root of that is 26.7. And that makes much more sense as an answer. A side of 13, a side of 24, and a side of 26.7 could make a triangle. This next slide was just a page to practice the two important keys. Can I identify which law I'm going to use, and can I write down the formula? So I'm going to start by looking for partnerships. In problem number 1, I have a partnership here, an angle and a side across from each other, and I have a partnership here, a side across from a variable. So this will be the law of sines. And I can set up sine of angle x over 12 is equal to the sine of 112 over 25. Notice the instructions say don't solve. They just want us to practice setting it up, and that would be it. I'm done. Now when I look at number 2, I start out with that partnership across from each other, but notice when I go to look for a second partnership, no angle, and no way to find either angle. So it's telling me that I cannot use the law of sines. I'm going to have to use the law of cosine. If I use the cosine rule, then I need to set this up with this partnership. X squared is going to equal the other two sides squared, so 16 squared plus 15 squared, minus 2 times the other two sides, 16 and 15, and then that multiplied by the cosine of 87. And I would work that out to figure out what x was. Let's look at next one. Again with 3, I'm going to look for partnerships. I start out by noticing that I have a partnership going this way, but this side does not exist across from an angle, and this side there's a missing angle, so there isn't enough of the right information to do the law of sines, so this is the law of cosines. Then I'm going to look at the partnership that I have here. There's my variable and there's the side across from it. So in this case, I'm finding the angle and this is the side. So it's always the side squared, 30 squared, is equal to the other two sides, 37 squared plus 55 squared, minus 2 times 37 and 55, and then the cosine of the angle, which in this case we don't know, and we'll call it x. So that's the setup to work out to solve for x. Last one, looking for partnerships. I've got 100 across from x. Great. And then I look for the second partnership to see if I can use the law of sines. And there I have 42 and 56. So this is going to work out for the law of sines. I have 3 of the 4 pieces of information, so I can use the law of sines. And it's always the sine of the angle, in this case 100, divided by its opposite side, is equal to the sine of another angle, 42, divided by its opposite side, 56. Now we have a couple of problems for you to practice from start to finish. I'm going to recommend that you pause the video and try these on your own, and then you can start the video and see how well you have done. In the first one, I'm going to give you a hint and say just solve for x. The problem does ask you to find all the missing dimensions, but in the video we really don't have time to find everything. That missing angle would be easy to find. Take 180 minus 138 and 20. And then we could also solve for the other side, but for right now, solve for x. Go ahead and pause the video. Okay. Hopefully you looked at this and you said, well, there's an opposite partnership and there's an opposite partnership. And I have 3 out of the 4 pieces of information, so that means this is the sine rule or the law of sines. And I have a couple of choices on how to set that up. I can put the side on top or the sine of the angle on top. I'm going to choose to put the sine on the bottom and the side on the top. So I'm going to say side x over the sine of 138 is equal to side of 8 over sine of 20. And the reason I'm choosing that is I like to have the variable in the top. And that means it's very simple to figure out. If I want the variable by itself, I need to multiply this side by the denominator, which is the sine of 138. That means this will cancel and I don't have to worry about it, and x will be alone. But don't forget, if I multiply one side by sine of 138, then I need to multiply the other side by the sine of 138. So this gives me x is equal to 8 times the sine of 138 divided by the sine of 20. I'm going to plug that into my calculator. And I'm going to be very careful. When I do 8 times the sine of 138, I'm going to hit enter, and then I'm going to hit divide by sine of 20, and I'm going to get x is equal to 15.7. X is by itself. I don't need to take a square root. I don't need to do inverse sine because it's just plain x that I was looking for. I have found what the side measures. This one is the most complicated. It asks you to find the measure of sine c. I'm going to give you a hint. In the first place, start out and solve for x. And once you have x, then try to find the missing angle. Go ahead and hit pause and see what you can do. All right, when I look at this one, there is so much missing information. I see that I have 2 sides and an angle that's included, and that means that at best all I'm going to be able to find is this opposite partnership, and that's going to require the law of cosines. So for step 1, I'm going to use the cosine rule or the law of cosine, and I'm going to solve for x. So in order to solve for x, x is my side, So I'm going to write x squared is equal to, so that means b and c are the other two sides, 15 squared plus 19 squared minus 2 times 15 times 19 cosine of 120. Now the nice thing about this is I can type this into my calculator just as it's written, and or I can do the parts individually, but I'm going to go ahead and type everything in. And when I get done with 15 squared plus 19 squared minus 2 times 15 times 19 cosine of 120, put that in my calculator, hit enter, I'm going to have x squared equals 871. But I got to watch it. This is x squared, not x. So to get out of this, I take the square root of both sides. Square root of x squared is x. Square root of 871 is 29.5. So x is 29.5. Well, that's great, but that's not what the question asked me to find. The question asked me to find the angle C. So this is where we have to do a step 2. I couldn't find angle C because angle C, there wasn't enough information to do the law of sines. But now, angle C is across from 15, and the 120 is across from 29.5. So now I have enough information to use the law of sines to find the measure of angle C. So with the sine rule, or the law of sines, I'm going to set up the sine of the angle, and let's call that angle, shall we call that angle Y? So the sine of angle Y divided by its opposite side is equal to the sine of 120 divided by its opposite side, which we found to be 29.5. So I need to multiply this side by 15, and I need to multiply this side by 15. Cancel that out. Sine of y equals 15 times the sine of 120 divided by 29.5. You'll notice that I put the 15 in front. You want to be very careful. If you are trying to enter this into the calculator and you type sine 120 and then times 15, it may take the sine of both of those and not do what you're asking it to do. So if it were me, I would make sure that I had the 15 on the other side. So now I would, in my calculator, type 15 sine 120, hit enter, then divide by 29.5, and that's going to give me the sine of y is equal to 0.4404 when I round. Once again, I have to be careful at this end because y is not yet by itself. What am I trying to find? I'm finding an angle. So this means I need to convert this to inverse sine of 0.4404. That will give me y. Type that into my calculator, and it will tell me that y is 26.1 degrees. I hope this helped you. If you were watching this for the second time, I hope this helps you with your homework. Go through, match up your homework problems to each one of the ones that were done in the video, and that should help you get through it and bring all the questions you have to class tomorrow.